Thank you. Miigwech. Gracias. Umbiagindi kunduaha. Thank you for being here tonight. Thank you in all my languages. I'm Dr. Layne Kalbfleich, and I'm an educational psychologist and a cognitive neuroscientist. And I studied learning from the outside in and the inside out. That's the informal definition of all of that verbiage. I'm a professor at Northern. I teach teachers, and I work in private practice around northern New Mexico, supporting families and children, and supporting organizations that support families and children. My special curiosity as a scientist and an educator is talent. And I've spent a lot of time looking at the functional neurologies of people that live with disability and mental illness, but also possess really beautiful strengths and talents. So as Tom said, I started this talk in the fall, and we're kind of picking up where that talk left off. So I pulled a few slides in from the first night just to catch everybody up, but also to create some continuity for those of you who are just joining us tonight. So thank you for being here. So the premise of what I do as a combination of being a scientist, a psychologist, a teacher, a cognitive neuroscientist, trained in nuclear MRI, is that science is the story of the group average. You know, in order to publish something in science, there has to be a grand mean. There has to be statistical power to support the inference. And so we learn a lot about ourselves from science. It's an important tool. But at the end of the day, we are all individuals, and we're all individuals with differences. And so what I do in private practice today is take all of the learning that I've amassed, and I apply all of that learning a case at a time to families or children or organizations, helping people and organizations get better at what they do, apply the learning sciences as they are now to what we know, and kind of try to help people have a better fit in their own environments, in their relationships, in their workplaces, and in their own learning. So everybody's curious about the brain. This is a slide of about 15 books on a bookshelf in a mall in Northern Virginia quite a few years ago. But if you go to a Barnes & Noble or a bookstore or browse your e-reader and search for brain, that word, you get so much information, right? And it makes it look like there's the reading brain, the drinking brain, the thinking brain, the feeling brain, the sad brain, the happy brain, the exercising brain, the couch potato brain. Everybody's curious, except that we have just one brain, and it does all these things, and it cycles through all of these states and processes. And so tonight I'm going to hopefully simplify some of that for you and teach you a little bit about the relationship between creativity and mental illness. Because if you turn that into a question, is there a relationship? Yes, there is, and no, there isn't. And it depends on what you're talking about. So, as I said a moment ago, my main curiosity for a long time has been talent. And not just talent in the way you think of artistically, but what is the talent that the human neurology gives us? And how many different ways can that be looked at? And in the learning sciences, there's a theory, it's called Constructivism. And it simply means that each person makes sense of their own knowledge on their own. And if you're not doing that, it won't stick. When I work with teachers, I say, you know, you couldn't digest somebody's food for them. Why do you think you could digest somebody's knowledge? Or stuff a person with knowledge? That person, each one of you and me, have to make sense of things in your own way in order for it to really stay with you and serve you. The last time that I kind of had a megaphone on the world stage was a journal that published back in 2015, 13, on Constructivism. And this was a journal where several, how many? Almost 90 authors contributed from all over the world, looking at things like reading, dyslexia, mental illness, curiosity, different kinds of ways to look at how we study ourselves. And I pulled this screen to date because the last time I was here, 287,000 people had pulled that down. It became an ebook. Once you get to a certain critical mass, the journal turns it into a book. And as of this afternoon, it's up to over 300,000 reads. So makes me happy as a practitioner and a scholar. But talent is not a new commodity, and it isn't even fuzzy the way the scientific world suggests. Well, how would you study that? It's too abstract, too hard to pin down. And what my counter would be, well, look at these artifacts. One from Chaco Canyon, not far from here. One, the Parthenon in Athens, Greece. You can go all over the surface of the earth, and you can see signs of human talent and ingenuity everywhere. Old signs that for a long time we've been pretty sophisticated about what we know and what we do. Here in the Southwest as well. Talent, it's such a fundamental idea to me that you can study it in other species. And there are things that other species teach us about talent. Dolphins have taught military linguists about communication systems. Crows, we know that crows can steal from each other, they can problem solve, they can build tools. There are things that we think are unique to us that actually other species can do too. And so, kind of one of the initial premise of all of this is that part of your brain you more carefully inherit from your ancestors and your family, and another part of your brain is wide open to experience and what's happening to you right now. And so the purple arrows are all in the front of the brain, right here, your frontal lobes. And your frontal lobes spend the first 25 years of life maturing. And when you think about the kinds of things that we ask people to do before they're 25 years old, it's pretty staggering. People drink, people marry, people go to war, people study, people do all kinds of very adult things before the most erudite part of their brain fully matures. And the executive functions are called that because they help us execute. And they help us manage ourselves, and they help us manage everything else. Those are kind of the two, that's the most basic breakdown of what these 8 or 9 skills up in the front of your brain do. Manage yourself and manage everything else. So that's the part that you get from your ancestors and your family. That's the part that you're born with. Good news, bad news, it's just you get from your biology your executive skills. Are they influenced by the environment? Yes, they can be influenced by the environment. There are a lot of training studies coming out, especially in kids, showing us that if we intervene properly, that we can help promote executive skills. And one of the disabilities I've spent a lot of time on is autism. And so in autism, you can see where self-management might not be really developed, but intellectual management can be highly developed. And so it's taking cues like that if you've got strong executive functions in one side or the other, that you can take those and use them to go to the other side and help a person build skills that don't come naturally. The green arrows are your language areas, your emotion areas, where memory is seated, kind of on the sides of your head and your temporal lobes. The amazing thing is that those areas of your brain are more open to experience than they are under genetic control, which means God, whoever he or she is, has a sense of humor because you kind of inherit your executive within your family lineage, but your ability to seek information and education, to be excited and passionate, to absorb information and experience is unlimited. Okay, that's an important feature of how we're put together. And so here's a schematic of the brain. So the blue frontal lobes are where I've been talking about where the executive functions sit. And they all have clinical names like shift and emotional control, and inhibition and working memory. But these are kind of the the plain spoken ways to think about what your frontal lobes do. They help you deal with a hard task. They help you tolerate ambiguity when there's uncertainty in a situation. They respond to novelty when something new comes into your experience. They help you remember things. They help you plan now and into the future. And they help you anticipate consequences of actions.
Where would music come into play in this? Would it be in the frontal lobe?
Music engages the entire brain. It's one of the reasons it's such a powerful medicine. Yeah. And so, aside from, I'm going to kind of build on what I'm talking about. The first principle is that your executive is more inherited, but your ability to get experience is completely open. Okay, there's a giant open door in your nervous system for chosen experience. The next thing is that when we talk about the brain in such formal terms, everything sounds so technical and dry. But really, what I want you to realize is that the brain, it's not a thinking machine that feels, it's a feeling machine that thinks. And there's a major difference, because if it's a thinking machine that just happens to feel, can put some feelers out, then it isn't really serving you well, because you have a brain to help you survive. And so you have to flip that and realize that your emotional systems and your sensory systems, those are the big antenna out in front of you and around you, gathering information for your brain to think and reason and logic with. Okay? And so here's where one of those intersections comes in about mental illness. That I've heard mental illness described as a break from reality. You can break from reality because of certain conditions and certain circumstances. Trauma can do that to you. But breaking doesn't necessarily have to be bad. And so when there's a crack, and if we think about mental illness as kind of the system is moved or shifted in a way that it doesn't normally do, that it isn't supposed to do, but it creates an opening, it creates an awareness. Some of those sensory and emotional antennae come out of places that are usually a little more covered up. And so there can be a benefit to that opening, to that perspective, the ability to see something in a way that maybe nobody can see in the moment. The key is bringing somebody who's having those kinds of experiences into a situation where they can express it artistically or verbally or make sense of it emotionally, to have an insight about their own function and their own well-being. So this was one of the last slides in the fall talk, and I wanted to revise it and bring it back here, because what this complicated slide is showing, you see a lot of slices of brain. And under the first column, it says stable learning state. And under the middle column, it says baseline, which is just the people that were participating in this fMRI experiment. In order to see something, you kind of have to gauge people doing nothing. And so the baseline state. And then the last column, it says the flexible and agile state. And so people in the brain imaging experiment that created these activations, they were solving really hard visual problems. And the visual problems looked like line drawings, nothing resembling reality, just complex kind of puzzles. And let's see if I have that. Yes. So here, they were solving problems that looked like this. And these are called matrix tests. And this is a matrix, and you have every piece of the puzzle except for one, and one of the four is going to solve that matrix visually. And so as they were solving those problems, we were presenting their visual cortex with emotional images. And the emotion on the top, you see a little boy who doesn't look like he's doing very well. And that's supposed to represent a negative state. You have a lady on a telephone in an office. That's supposed to be the baseline. Although that makes me chuckle because there are people who won't look at that and think it's the baseline. They'll have feelings and opinions attached to it because everybody's had some experience in that situation. And then the last picture, there are two people on bicycles, clearly enjoying themselves. Well, these are pictures out of a huge database of images that have been normed by the National Institute of Mental Health to track emotional systems in the brain and how much arousal there is, whether there's a positive reaction or a negative response. They have normed these to have consistent, say this will bring a positive, this will bring up a negative. And so my question in the lab was, if you have people solving these visual puzzles, but you create an environment or an emotional tone around that, how will that influence their logical reasoning frontal lobes? What will that do to the brain? And so what you can see in the final column over here, the brains, you can see the red patterns. And you can see from negative to neutral to positive that those patterns are not all the same, right? They're different. And those differences are the response to the emotional environment that people were problem solving in when they were doing these problems. And so those cartoons, if you take a brain and you kind of slice it like a bread loaf from the top to the bottom, break it open, these three pictures are these cutouts to show us that when somebody is in a positive state, surrounded by a positive emotion, doesn't have to be super excited or super happy, just kind of comfortable, ready, and open, that this is what the brain looks like. That on both sides, you have these yellow activations, which show that there's metabolism happening. And the brain kind of opens up like a catcher's mitt and says, oh, I'm ready. I'm ready. This is good. If you give it just a little bit of negative emotion, just a little bit, not enough to trigger a negative response or emotional upset, the brain says, oh, I'm ready. And it kind of, if it were going to, I'm personifying it, get up on its toes as if it were about ready to volley at a net playing tennis. The activations switch and they get a little more precise. And that's a brain that's really ready to do something that it's about to do and knows how to do what it's about to do. And so the insight that comes from this is that when, again, back to that table of books about the brain doing all these different things, that we've been in an era of neuroscience where one image will go up and say, well, this is what the brain looks like when it reads, or this is what the brain looks like when it adds and subtracts. But what we know now is that those are the basic systems, but those basic systems are called on depending on the emotion of the person in the moment and the kind of context that they're in. And so this is another insight about therapeutic measures and what creativity means to people who have mental illness and people who don't. That it's the environment around you that determines what comes out of you and what helps you from a brain point of view when you're creating, when you're reading, when you're working, when you're relaxing. And so it's a constant interplay. There isn't just the brain doing one thing and here's the particular piece that lights up. And that harkens to your question about music. One of the ways that music is such good medicine is that because of the stimulus that it is, how sensory it is, it calls on the whole brain at once. And so brains that might be breaking down by mental illness or a disease, we see in Alzheimer's disease, the last function that survives is music. And that's because music coordinates and tightens things up. Brain systems, especially ones that might be a little bit wobbly or disconnected on their own, music seems to kind of recohere everything and bring somebody into a moment where they are having memory, they're having emotion, If they're artistic, that might come out as expression. But that's, we're learning a lot about music and why it's so powerful. I have research colleagues that study synchrony and what a person who is naturally good at being on the beat, and you think, how boring, right? I'd rather be syncopated. I'd rather be kind of spotting around. But they've been looking into attention and young kids. And if synchrony, if somebody naturally is good about being on a beat, does that mean that their attention systems and how they're developing their frontal lobes, especially in childhood, is there an advantage there? And then me being me, I would say, well, there probably are advantages there for developing emotional control and things in childhood that help you do better as an adult. But if you're more naturally off the beat, I think there are strengths there too. And so we have to balance the questioning. But other of my colleagues in Chicago, Nina Kraus and her team, they've been looking across developmental ages. They've looked at high school. I believe they have a middle school paper out. But they've been looking at what musical training does to brains. And musical training tends to develop a brain that's more resilient to distractions. And one of the initial ways that they looked at this, and that the paper was in that journal I just showed you where the 300,000 plus views, but they looked at high school kids who went through 2 years of musical training, and the control group were peers who were exercising instead of being musically trained. And then at the end of 2 years, they trained them on a whole bunch of tests just to see how fast their reflexes were and how resistant they were to distraction. And the kids who had been in musical training, their reflexes were faster. They were better at managing complexity and conflict in the environment. And so, no matter what you're suffering with or working with, or at what stage of development you are, if you're musically inclined, that's a really good tool. It's an important tool for you to have and to use and to develop, because it can help keep you well in some of these ways. So the lesson from this busy visual slide is that it isn't just a system of the brain doing one thing. That's the genesis of it. That's the beginning of it. But depending on what's happening around you and the thoughts inside of you, that determines other systems that either come to enhance that skill and that knowledge or compete with it. So here's your palate cleanser. So if you were here in the fall, I explained this, I'll explain it again. Talking about neuroscience and trying to make it friendly to the public, there's a lot of vocabulary involved, there are a lot of images involved. And so after a couple of important points, I like to put up a picture that I took just for people to kind of relax for a moment, clear your mind a moment, look at something beautiful, and then we go on to the next point. Okay. All right. So the next piece, simple sentence. The brain wants stories. It doesn't matter if they're verbal or nonverbal. If none are available, it makes its own. What do I mean by that? Well, I'm going to explain this over the next few minutes. But our brains are wired for stories. And I love talking about this anywhere, but especially in New Mexico because of the oral histories that are so prevalent here. It's such a value that it's an intrinsic property of how we're all put together. And it is a value that is supported and tended here in ways that it isn't necessarily in other places. So this is another busy slide full of pictures, but the pictures are from my old fMRI laboratory because we were wrestling with this idea of stories at one point, and that rainbow mural that you see was what got created out of a big story workshop because if you've ever had an MRI, how many of you have ever been in an MRI? Right? They're cold and noisy, and they're not very nice places to be most of the time. And so when you're trying to study the human brain and how we function, you have to come up with creative ways to make it comfortable, make it exciting, make it palatable. And so that rainbow, on the left, there are images of the past, and on the right, there are images of the future. And on the screen, the short one above, are images of flight. And all the kids that we were involved with at that time, we brought them together for a day and said, well, we need to create a story for our MRI. What should it be? But there were so many stories that came out of that day that the mural of the time capsule and the time machine was created, so that every time a person came into the lab, we would say, you're going to help us contribute to science. And the brain is wired for stories. And do you want to go forward or backward in time to help us? And so that was mostly with kids. So they would choose a point in time, forward or backwards. And every time they came, we would kind of wrap their story around that time point and their curiosity and their interest. But the brain image that you see up there, that is a brain talking to itself, essentially. It's a state of the brain called the resting state. Let's see. Where is it? I'm going to show you this. Don't worry, I'll backtrack a little bit. But the brain's resting state, here's the formal definition. Distant brain regions that become connected into a synchronously active network when an individual is not focused on the outside world, and I can't read my blue print, but the brain's resting state comes out when you're reflecting, self-reflecting, when you have autobiographical memories, or when your mind wanders. And so this resting state is part of your functional brain. So it's kind of like the brain reading or calculating or reasoning. Only those systems are what I call do systems. They do things. The resting state, it doesn't do like the other systems do. It's an autonomic system in your brain. It's kind of like your heartbeat and your lungs. You don't tell your lungs to breathe. You don't tell your heart to beat. There's an autonomic system inside of you that does that. So the resting state is the autonomic system in your brain that helps you balance the internal world and what's going on around you. And it's kind of a buffer, okay, or a cache, if you will. So let me backtrack for a second. Go back through all these. Okay. So this resting state, what it looks like is a brain talking to itself, which is where that simple sentence came from. The brain wants stories. If none are available, it makes its own. Because when you're resting, when you're doing these things like reflecting or your mind is wandering, like tonight, you're all sitting here. Hopefully you're still really interested. And even if you are, your mind is still going other places, because that's what minds do. That's the way we're built. And so I worry in education because it's one of the biggest misunderstandings about how we're made. Because a teacher will say, you're daydreaming, get over here. You're off task, you should be doing A, not B, and we stress people out, basically, for this capacity that we all have naturally. And so in my dream of the world of education, we take care of the resting state, we incorporate the resting state, and put away some of the stress and anxiety that we've introduced to ourselves. Like, we've really kind of crossed ourselves in this way. So the resting state is the brain talking to itself. And it is influenced by exercise. It's influenced by meditation. It's influenced by disease. It's influenced by trauma. And we know that traumatic stress, it can alter a resting state in a person. And we know that diseases can. some of the first diseases that were looked at when scientists started to look at more closely at the resting state were autism, schizophrenia, and Alzheimer's. So back to the story, though. I have a story to share with you about how that insight came to be in my mind. There was a year where I was invited to the Great Apes Trust in Iowa, Des Moines, Iowa, I believe, to participate in a documentary that the BBC was doing on orangutans. And so up in the right-hand corner, that really beautiful face of an orangutan, that's Azy. And Azy used to live at the National Zoo, and one of my friends and colleagues has taken care of him his whole life. And so Rob said, well, come on out and be a part of this documentary, because they were trying to show the skills that great apes have against very young children. One of the things they were looking at was the Rouge test. And so babies, before they're about 2, you could sit them in front of a mirror and they won't recognize that they're on the other side of the mirror. But somewhere around 2, if you put lipstick on their nose or rouge on their nose, they'll recognize that it's them. And there's a key shift in the development of the mind that happens. But that turns out it's one of the things that isn't unique to humans, because apes can be trained to also have that self-awareness. So that's why I was there. But then as an aside, the orangutans there, they share kind of a compound with bonobos. And bonobos are apes that are matriarchal. So the mamas run the show. And so that up there that's Azy. And Azy is not the matriarch, he's the patriarch, but he was the partner of the matriarch. Azy passed away a couple of winters ago from the flu, but when Azy was with us, he was the bonobo that knew more of the English language than any other animal in captivity. And so watching the people communicate with these apes, they would use 3 ways. They would physically talk to them, they would sign, and they would use those color boards. And each of the checkers on that board is a different symbol. And so somewhere between verbal and sign and pointing to objects on the colorful lexigram board, they could put sentences together and communicate with each other. And I knew about that, but I'd never seen it. I'd never witnessed it personally. And let's see. Yeah. So there's Pam Venetia on the right. She's the matriarch. And this is Azy, her partner. And so picture this. The day that we're making this movie, we're snowed in. It's the worst ice storm in a decade. And we're at the Children's Museum downtown Des Moines. And one of the scientists comes out in a Jeep and says, come on, I'm going to take you out to see the apes. And so we're driving through this terrible weather. We're the only people on the road. We go out into rural Iowa. And when we finally get to where these guys live, you walk in and it's a round space. It's almost like walking into an aquarium, like teal green walls, and the plexiglass between you and the apes is bowed. So you really do feel like you're kind of in a globe. And so here's Pam Venetia sitting in front of a flat screen TV wider than I can stretch my arms. And she's got a blanket over her head, and 3 of the kids are tumbling around on the floor, and Kanzi's on the other side. And it looked just like a human family on a snowy day, relaxing in the living room. And I said, well, what is she watching on that really fancy TV? I don't even have a TV is that fancy. And they said, well, she's watching a story that we made for her. And I said, really, tell me more. And they said, well, she asks us for stories through sign, through the lexigram, and she will give us the objects or characters. There are characters on this board. There's a fuzzy bunny, there's a teddy bear, and she will say, take the fuzzy bunny and the teddy bear, they should go out into the woods, they should find these things, bring these back. So they're very simple narratives, but they would take the narratives and they would go out and make skits and then bring them back for the movies, and she would play Siskel and Ebert. Thumbs up, thumbs down. And I'm standing there, and literally chills went right through me watching that interaction happen of her kind of giving her opinion of the little film vignette on that amazing television. And that was the moment where I thought, wow, the brain really is wired for stories. That isn't even a human capacity. It's something that we share on a limited fashion across other species. And so, those are the layers of how that insight came to me about story and how we're put together. And so this is a bigger picture of the brain's resting state. But to break it down a little bit, these side areas, so these are the areas of language. These areas back here, kind of at the crown of your head, that's where your part of your sense of self is. That's where self kind of lives, gets made sense of, self versus everything else in the world. And then up front, that's like right up here in your executive, and that's some of the most sophisticated reasoning tissue that your brain has. And so if nothing from the environment is coming in, the brain kind of closes itself off and has this internal balancing state, and it keeps you healthy. The other interesting thing is that when somebody goes into an MRI scanner, if the task is too boring or too easy for them, they can be answering, pushing the A button or the B button. They can be doing your task, but if it isn't challenging their minds, you see the resting state. So that adage of you can do something with your eyes closed, there's some physiological wisdom to that. Because if something's not hard enough, your resting state will just kind of, keep doing its thing. So there are other people looking into this that are also thinking it might be where imagination comes from. Because if you think about the brain, it isn't a completely closed system. Because if it were, you couldn't learn, right? There has to be that flexibility, that plasticity at the neural level that allows you to incorporate that experience, to learn as a function of your experience. And so you think about, well, how would you, it's the riddle, how do you keep a closed system, the package that functions across your lifespan, but how does new stuff get in? And so on a cognitive level, one of the ways we think that new things get incorporated or presented is in this resting state space, because it's a space where things get integrated. And when you layer that with sleep, with a good night's sleep that's designed to get rid of things you don't need and consolidate things that your brain wants to keep, that's kind of where things get a little murky. That 1 + 1 doesn't necessarily equal 2. And so back to what I was saying about mental illness, and that one of the things mental illness does is it alters your state of reality. It alters your perception of reality, right? And so if you look at that the right way, if you treat that the right way, thinking about the executive functions, what's stronger, the intellectual side or the self side, and say, okay, whichever one is stronger, I'm going to use that skill to help make the weaker ones better. If you think about the resting state and keeping people well, even if you have mental illness, you can still practice wellness, right? You can still eat well. You can still try to sleep well, because sometimes sleep is an issue. There are patterns you can establish for yourself that are well, that can support you. And so these wirings, how we're put together, these are the clues for how do you find the positives and how do you leverage the positives against what the neurology is doing at the moment. So this is a composite image of the resting state, looking at what I was telling you before, that it's influenced by sleep and it's influenced by disease. So looking at Alzheimer's, autism, schizophrenia, meditation can influence it for the better, and age influences it too. It changes with you, but it's a property that's intrinsic to your neurology. Do you have a question?
Would language affect it? Like the resting state, like creativity and language kind of go
So language, it's a complicated topic because yes, in that in cognition, when you see how individuals are problem solving, you often see the language areas light up, like if they're self-talk. And so that's not a direct verbal, somebody who's saying something or doing something with language that's kind of coming out, but it's internal, and you can see individual differences of, if Tom, if I had you solve a problem quietly and Jessica, you solve a problem quietly, like if I were looking at your brain activations, you would be using different strategies based on what you do comfortably. Are you going to look at it? Are you going to talk it through? And so in that way, language is an important piece of the picture. But other than that, the resting state quiets when you do something, and language is a production. Okay. So that's kind of the main distinction of the resting state, that all the things that you do, the do systems, speak, reading, writing, arithmetic, all the things you do, when you are in action, in motion, the resting state is quiet. But as soon as you stop and stand still and take a breath and pause, close your eyes, take a moment, that resting state reasserts itself because it's more passive. But it's a balancing. It's always responding and adapting to what you are doing or not doing based on the environment. Question?
Could you please go back to the previous slide? I was noting some stuff, and now you got to catch up.
Oh, okay. Sure.
Okay.
Got it?
Thank you.
You're welcome. And so this slide is from data in a study that I was a part of. I was a professor of neurology at Georgetown for 2 years, and we were funded with Johns Hopkins and Children's National Medical Center to look at kids with autism. And one of the things that we were able to do was look at kids with autism doing things, reasoning, paying attention, doing very logical things that their brains are very good at doing. But we were also able to look at their resting states, because when you study the human brain, you have to have that comparison of the brain resting and then the brain doing something. Otherwise, you don't know where the value added is. And so when we looked at the resting state of our kids with autism, what you see in these colors is that the TD, those are typically developing kids, the control group, all of the resting state areas are red, which means that all of those areas are connected the way they're supposed to be connected up. They're in concert together, right? Which is what the resting state is. It's a balancing system. But in our kids with autism, you see purple, green, blue, and red, 4 different colors. And each of those colors shows a part of the resting state that's in and of itself in those kids with autism. And so if you think about this, the pattern would look different for schizophrenia, different for Alzheimer's, but the resting state in mental illness doesn't quite connect as well as it does in a typical person, okay? And so some of the consequences of that are some of the struggle, I think, because the resting state is a recovery mechanism. It's part of your homeostasis. And so the recovery mechanism is built a little differently when you have a disease state like that or a mental illness. And that's important to know, because I've also told you that it can be influenced by meditation, by exercise. Back to if the person is not well, you can still be in well routines and in a well environment, because eventually, I would hope we don't have all this, this is science that is ongoing right now, but the brain is plastic. It's designed to respond to experience. So there's a hope that the resting state could be influenced and could be better connected, because that's part of our body's resilience factor.
Have you been able to test that as far as the improvement with whether it's meditation
My research hasn't done that, but that's research that's ongoing. I mean, this is kind of a doorway in and around the do systems, because if it were just about doing, I'm going to teach you to be a better calculator, a better problem solver. I mean, that's what training does, right? We've all been in situations where we are training for a job or a position or a role or just something that we want to learn to do. And those do systems, what I hope you're starting to appreciate, are just the surface of the problem, because underneath the doing, then you have this resting state that's managing and calibrating and helping you be resilient. And then there's the environment that's changing all the time and that you're adapting to. And so all of these different layers are kind of doorways in to wellness and therapy. And we're living in an age where we're getting smart about looking at things just beyond medicine and chemical intervention, but looking at how our environments can help us. And when you think about what's the role of a parent to a child, a parent is there to make sure that a child learns the behavioral policies of the world. Don't do that, do this. Teachers in classrooms teach kids the behavioral policies of learning, or they're supposed to. In communities, we hold each other accountable in these similar ways. And so it's not too hard to imagine that as we're starting to learn with these softer things like meditation and that you can't see so directly and measure so directly can have a huge impact on how we're living, what our quality of life is.
Is that where creativity and like if you're doing art, that it can help, just like meditation and all of that, like trick the brain that may be suffering from depression or bipolar, trick them into a more healthy resting state.
What?
Like,
Does what release dopamine?
creativity and stuff.
So the chemistry of focus, being focused on something, the neurochemistry of feeling good about something, of wanting something, of feeling motivated, that's dopamine driven. And dopamine in your brain is a buffer chemical. It settles things down. It's how you focus. People that have issues with attention that don't focus well, one of the organic reasons for that can be low dopamine, that there isn't enough of a showering system to quiet the brain. Instead, everything gets in. All the sensation from all around you just travels right in. There isn't a filter. And so when you're creating, a lot of the feel-good chemicals are created because it feels good to create, right? Or we wouldn't do it. So creativity helps tip the scale between focus and pleasure and perseveration. And so you see perseveration in OCD. You can see it in autism with the rigidity. You can see it in people who are traumatized. And that kind of rigidity can become non-productive, right? But you can watch someone perseverate, and if it's quiet, it doesn't look like there's anything wrong. But you can also watch somebody quietly who's deeply, intently focused on something that they're doing. And the brain state, the behavior might look the same, but one is what we call flow and creativity. Csikszentmihalyi, one of the big creativity theorists, talks about the flow state and that feeling of just losing time and being in a moment with something that you're doing. And that's called flow. But flow is the positive sister of perseveration, because perseveration is also being hyper-focused on something, but it's repetitive and it's painful. It's not productive. And so with creativity and mental illness, that's one of the salves, the potentials, is that you could take, if someone is in a moment of perseveration, it's not healthy for them. And if you can therapeutically have them involved in some play to co-opt that perseverative state into something productive, then you begin to show them other things are possible. Let me tell you a story. There's a little boy that I have worked with who has autism, homeschooled, because the demands and contingencies of the class are too much. And one of the things that I help kids learn are other ways to create what teachers want from them, like the big research papers. Okay, that 12-page paper looking at you 3 months from now, and their kids with disabilities and autism don't have the planning skills for it, don't have the temperament for it. They might have dysgraphia and not write well, and so there are all kinds of obstacles to that assignment, and no scaffolding for using their natural minds to get what they're supposed to be doing. And so I use assistive technology with kids, and I show them how to concept map on a computer that allows them to reflect how their brain sees a topic on a screen. So it's coming out of their mind the way they see it. And then after the map is mature, they press a button and it becomes a draft of a paper, or it becomes a draft of a PowerPoint. And all of a sudden, there's that scary product that the teacher wanted from them, but they didn't have to go into it in pain and stress and anxiety, and I can't do this. And so I have a kiddo that I've been working with who over a month's time, like, we chose an incredible topic, based in fantasy and science fiction. So, no real world stuff to hang on to. I've been schooled because it's not a world that I know or inhabit, but it allowed this person to become my teacher because this is the topic that really meant a lot to him. And then we whiteboarded it, we put it on a whiteboard. And I took pictures of those whiteboards as he put them together week by week. And then we put them into the technology. And then finally that went out on the internet to do research. And then that became a paper. And so here's a kid with deep mental illness, several diagnoses on his roster, who doesn't think that he's capable of learning, even though his IQ is super high. And over these weeks where it feels like he's maybe pushing and testing the boundaries, and why do I have to work with Dr. K? And at the end of it, in spite of himself, he sees that he's been able to make progress, and that he is learning, and that he is deepening what he knows. And all wrapped up in that, it's not the perfect straight line. He had good sessions and bad sessions, and sessions where no corner of the room was untouched or uncovered by him because he couldn't sit still and he couldn't look me in the eye. But we could get to periods on the wall where he could show me what was in here by drawing it. And then I helped him bring it into the technology. So, this is what I mean by there are clues about how we are all wired as human beings. I call it a playbook. We're half what everybody is, and then we're half what makes us who we are, because brains are as unique as fingerprints. We could all go and be ID'd by our fingerprint, but we could also be ID'd by our brain that way. It's that individual. So these clues about what everybody gets, and you take them into a personal space, and especially in mental illness where there could be those openings, there are these tipping points between, for instance, flow and perseveration. And you could conceive that you could take somebody out of a state of suffering and back into a positive state by just leveraging the moment that they happen to be in, right? And in the executive functions, again, saying, is their self-management better than their information management? Great, we're going to start there. Or like in autism, their information management is usually better than self-management. Okay, we're going to start with the intellectual ability to, for patterns and codes, but we're going to find analogies to make that social. And we're going to help improve the social gain of that person based on what their playbook is, how they are naturally put together. So, we have these clues. So this is a study about relaxation to show that when we do take the time to relax, that it does enhance our brain's capacity to resist distraction. And so the pictures are probably the best shorthand. When you look at the brain on the left that's got gold and red in it, that's a hot brain. Okay, in neuroimaging, those are hot colors, which signal there's a lot going on, a lot of mental activity going on. And that could be sensory input, that could be rumination, that could be agitation, could be any number of things. But that brain on the left, there's a lot going on in that brain. And then after 10 minutes of meditation, you see the blue brain, right? And all of that heat, literally the red, has calmed down. And that brain has calmed down. So that's a cool brain. That's a relaxed brain. And so within 10 minutes, this is how plastic we are. Like some things, they say you have to practice and practice and practice. Or, in psychiatric world, no, you're going to have to take medicine for 6 weeks before we know if it's going to help you. Long ramps, right? Long ramp time. But we're this plastic that in 10 minutes you can see, if you were wired up with this kind of equipment, you could see the impact that your choice to try to calm down and be still has on your system. It's that visible. I love this. Everybody should be quiet, near a little stream and listen. This is out of a book by Ruth Krauss called Open House for Butterflies. And if you don't know this book, I suggest you look into it, because every page there's like a kernel of wisdom like this, where you just look at it and read it and say, duh, of course we should do this. Bless you twice. So, especially in northern New Mexico, we're surrounded by beauty. We should take advantage of it. It's medicine. The influence of physical activity on brain function. Now, exercise was used as a control group to the musicians. Bless you. But it's still really important, So if there's one single thing you can do for yourself, keep moving. Because what we're learning about exercise is that exercise won't stop the brain from aging, but it can stop the key memory areas of your brain from aging. So there's a bit of arrested development that can take place in the memory areas of your brain if you are a physically active person. Okay? And so, Lordy, that's juniper, not a cold. Again, another physical image to show you that if you're physically active across life, certain parts of your brain will not age at the rate that the rest of you will. And those happen to be your memory and your sense-making areas of your brain. So keep moving. Stressed, this is what we do to ourselves, right? We can create stress for ourselves. We're all perfectly capable of doing that. Life creates that, illness creates that. But I want to give you a thought exercise to take with you about stress. And I call it almonds and cherries. And it'll be out in my book coming out at the end of the year. So the part of your brain that helps you learn and remember things looks like this. Looks like a seahorse. And so it's called the hippocampus, which is Greek for little horse. And the neat thing about that memory system is it is embedded in the tissues that process your emotions and your language. And so kind of wrapped in and around it, you have a little piece of your brain, looks like an almond. It's about the size of an almond. It's called the amygdala. And the amygdala is the piece of your brain that tries to hijack everything else. It's wired for negativity. It's exquisitely tuned to stress. And so when you're stressed and your stomach starts to get butterflies and your lungs are short of breath and you feel fuzzy and you can't breathe deeply. All of that, that's a lot of adrenaline in your system. And adrenaline, a little bit at a time, is good for us because it helps us get ready to do things. But when it gets to be too much, you have chronic stress and anxiety. But here's the thing. And if I weren't allergic to nuts, I would put an almond in every single one of your hands. But I want you to just imagine that you have an almond in your hand. And let me say to you, this almond-sized thing in your brain, this is not all of you, right? It's just a tiny piece of you. You are put together with a whole bunch more in your anatomy, neural and otherwise. So if in a moment you can catch yourself or teach somebody in your life to catch themselves that, yep, it's overwhelming and it feels like the sky is falling, but what's creating that phenomenon in your body and in your mind is the size of an almond. You're bigger than that. You can get on top of this. You can do this. Okay, that's lesson number 1. Lesson number 2 is that behind that almond-shaped structure, you have these nuclei that look like cherries or grapes. They're called the nucleus accumbens. And they produce dopamine. They produce the chemical that settles everything down, that makes you feel good, makes you feel motivated. 2 to 1, folks. Open your other hand. I just put 2 cherries in your other hand. Cherries are bigger than almonds, and you've got 2 in one hand and 1 in another. So really, if you can tell yourself the capacities in your brain to help you recover and come out of stress are double the physical real estate of the part of your brain causing you that stress. Right? And you're laughing, and this is good because that's part of the medicine of that. That if you can pass this on to people, that in a moment it's like almonds or cherries. What's it going to be? Huh?
I'm eating celery, and celery is good for stress.
Yeah. Celery's good for a lot of things.
Irony in the...
Yeah. So, you know, in a moment where you're dealing with somebody who's being overcome and overwhelmed, in a quiet moment, in a more relaxed moment, try this with them and just impart this and say, the next time this happens, the next time you're having a moment, we're going to do almonds and cherries. 2 to 1. And you are made of a lot more than just those small pieces. Yes, they're powerful pieces of our human anatomy. They help keep us alive. They keep lions from eating us and overtaking us. And cell phones and cars, and now that we're not in the wild so much. But this helps put it in perspective. Yeah. So, kind of to wrap up, you know, these ideas of the resting state, of using the strong executive functions to help the weak ones, are they on the self side, are they on the information side? Understanding that it is not as simple in your mind as having your brain do something, when the picture is that you're doing something, but you're surrounded by a context, an internal context and an external context that make it a whole bunch more complicated. Different neurologies show up depending on what's happening, which means there are a lot more doorways in for intervention than you would think, right? When we talk intervention, we talk targets, targeted intervention, shoot the arrow, right? Just 1-to-1. But our brains are more open than that. And our neuroscience is starting to show us how context influences what's happening inside, which is good news for mental illness, because mental illness can be a moving target. One in a person and as a category, and, you know, autism is a spectrum, ADHD is a container. You're kind of in one container or another. You know, we create a lot of complexity, but the most important complexity to understand is this one in our playbook. So we all have one. They're made up of characteristics that we all share, but outside of the common vocabulary and language and almonds and cherries, such, you have a playbook that's very unique to you physically and behaviorally. so this is just kind of a fun aside. I'm going to explain this in a minute. But note to self, this is about believing in yourself. If you were able to believe in Santa Claus for 8 years, you can believe in yourself for about 5 seconds, right? You've got this. And then there's this corn, hot outside, and the one behind him is all popped and says, shut up. So this is kind of where I challenge you. What I want you to take away is what have I said tonight? One thing that is made an impact on you that you think you can take forward and think about and reflect on a little more and kind of see if it starts to make a difference. And then what life experiences or talents do you have that might help maintain and strengthen your resilience? Because now that we know that things like even socializing and exercising and music, and these are things that we tend to share in communities, right? For ceremony, for celebration, for relaxation. Those are things that can be brought in therapeutically to help turn a moment that's not optimal, like perseveration, and help turn it into something else. Okay. And so within my practice, how does this all take shape? It happens, the playbook, that's what comes out of assessments that I give. I do psychoeducational evaluations, I do autism evaluations. I participate in the clinical arena, but I really work on a more holistic level to give people a balanced picture of themselves and to see where these doorways and these assets are. I work with kids in the same way. I help people who have questions about memory changing, because as our brains age, memory changes, and the media will tell us that we're losing it, right? You're losing memory. But actually it's a trade, it's not a loss. Things are being traded. Neural tissue is being traded. And by the way, some of that neural tissue changing leads to the capacities for wisdom and the capacities for more open problem solving and creativity. And these are studies that have been done in aging. So, we need to retool our conversation about memory as well, because when you think you're losing it, up goes the stress, which blocks you from what your natural capacities are and blocks all the good stuff from coming in to help you. And so it's all about what we tell ourselves. And then I work with organizations who have these same goals that say, how do we put this into funding? How do we put this into curriculums or programs or services? And so I work at that level, the collective level too. And so we don't have time. So we have about 15 minutes. So I wanted to open the floor for questions and conversation.
Is there some way that ADD can be like counteracted? Are there things that are
Yep.
beneficial?
Yep.
Like what?
Number one is exercise, because in attention deficit, in an organic attention deficit, there's not enough dopamine, but exercise is one of the things that elevates dopamine naturally. When I served kids at the college level, I had a lot of hyperactive athletes, college athletes, and they would not study until 9 o'clock at night. Most people think, oh boy, you should be, winding it up for the evening, but they would need to go to class, be social, be rambunctious, be hyperactive, go through a several-hour athletic practice that kind of drained them physically, and then their minds could were calm and open. So exercise will help a ton. Music can also help with that.
When you mention music, are you talking even early on? Were you talking about like playing music or just listening or both?
The skill I was talking about was actual expertise, so playing music, having musical expertise. But listening to music that's that entrainment that happens. It could bring a group of people onto a similar emotional page, perceptual page, faster than anything else. And hang on, she had a question.
I was just going to say something about memory that I've experienced some about memory loss, and my mom was struggling too. And it seems like stress is the biggest detractor, the biggest interference.
It is.
And we get so hung up on perfection or right and wrong, or very aware when we make a mistake, or we're convinced that, oh, we lost car keys, we can't find this, we're losing skills.
Right.
And I talk to her, or just talk to myself, it's like a Rolodex. We only hold so much.
Right.
And when a few things drop off, it's no big deal. We're too busy absorbing all the changes in the world changes around us.
Yep.
From decade to decade,
All
we're
the
changing
time.
our bodies. And it's just be easy with it. And and with vocabulary, I assured her, it's look, if you're trying to say lemon, just get to yellow, just get to lemonade, something close, we'll figure it out.
Totally.
Just kind of work through it, and then just having that easiness, bringing that into it.
Right.
It's kind of dropped off as an issue. It's once we don't make it an issue, and just realize we can still communicate, we can still function. Beyond that, it's the biggest thing.
Right. People will say, I could think of the word, but it'll come out about 2 hours later, or 3 a.m. when I'm asleep. But that's an important fact about human memory too, is that that's what I'm talking about. It's trade, not a loss. It's maybe it's gone to another location, and so it isn't where you left it, so to speak. And so you got to go look. Your brain has to go look for it. And so that's different than it not being there. And I often tell people, use your eyes to help your brain. We're so used to multitasking, and by the way, we're all terrible at it. We are not wired to multitask. Really, about 3 things is what the mind likes at any given time. Beyond 3, it's noise. And you see that in kids all the time. What did you want me to do? Have 5 steps? And no, I only heard you say X. Or a spouse will say to a spouse, I only heard you say this, or go there, or, I didn't hear like the 5 things that came after that, because the brain really likes about 3 things. And so we're terrible at multitasking. And so you think about your day, you're moving through your day, where are your eyes? Full speed ahead. But your keys are over there, and your jacket's over there, and, you're moving about your life, but your eyes are... And your body goes where your eyes go. Like if you ever learn to ice skate and they say, don't look at your feet, because what do? Boom, you're down on the ice. I used to figure skate. I learned that. Your eyes, your body, and your brain will follow your eyes. And so I tell people, use your eyes to help your brain. Don't multitask. Come in the way you usually do, but look where you put your keys. Decide right now that is where they're going to live in time immemorial. You're not going to put them any other place but that place. Use your eyes to help your brain. And it just takes a smidge longer. But there are a lot of dividends in doing that and having things mapped out and place memory. So
I wanted to say I appreciate how knowledgeable you are of everything. You ask questions and you know exactly how to answer them, and that's really great for a prisoner. Second of all, do you ever consider working with adults with disabilities?
I do work with adults. I work across the lifespan.
Okay.
Mm-hmm.
Would you work with me?
Yes. I'd be happy to. Yep.
Any more questions? Well, let's thank Dr. Kalbfleich for